So up until this point, we know some information about the graph of y equals a sine of bx and y equals a cosine of bx. We know that the absolute value of this coefficient a is called the amplitude, and it represents how far the graph will deviate from the x-axis at any given point. And we also know the period. So I want to go back over how we know this. We know that the sine of x and the cosine of x have a period of 2 pi. So x is going from 0 to 2 pi. So we know that bx goes from 0 to 2 pi. Now what that means is that bx is going to start at 0 and it's going to end at 2 pi. So we get these two separate equations. Now if we solve for x in both, we get that x is going to be 0 divided by b, which is just 0. X is going from 0 to, we divide by b again, we get 2 pi over b. So this gives us the period of a function that looks like this. So our period is going to be 2 pi over b for these types of functions. So just to reiterate, a, the amplitude, is going to stretch or shrink the graph vertically, while b is going to stretch or shrink the graph horizontally. And I should have said stretches or shrinks. So how can I fix this? I'll just say A will and B will. And there we go. Now the grammar is correct. So this is what we know thus far. We've got the graph of y equals a sine of bx, y equals a cosine of bx. A is the amplitude. It's how far we are from the x-axis. Our period is, how long it takes for a full revolution. And that's going to be given by 2 pi over b. So now we approach the next concept, which is what happens if we have the equation y equals a sine of bx plus c, or a cosine of bx plus c. Well, in this situation, the absolute value of a is still going to be our amplitude, but what is our period? So this time, bx plus c goes from 0 to 2 pi. So we get the following two equations. It's going to start at 0, and it's going to end at 2 pi. So let's solve both of these for x. So the first equation we're looking at, we're first going to subtract a c, and then we're going to divide by b. So x is going to start at negative c over b here. And then secondly, we're going to start off by subtracting by c again. So negative c plus 2 pi. And then we divide everything by b. So we get x equals negative c over b plus 2 pi over b. So what's happening? The graph of y equals a cosine of bx plus c and the graph of y equals a sine of bx plus c is going to start at negative c over b and it's going to end at negative c over b plus 2 pi over b. So if you look, it started at negative c over b and then it ended up there with just a little bit more with this 2 pi over b added. And so this 2 pi over b, as we saw on our previous slide, is still our period. Okay, it's how long it takes to make a full revolution, but this new value, this negative c over b, is going to be called a phase shift. And so that's the new concept here. And so we get the following. We get that the period of this graph is still going to be 2 pi over b, but this new concept called a phase shift is going to be given by negative c over b. And so what this is actually doing, we are going to get that adding c shifts the graph horizontally. So in class, when we have a constant on the outside, that's going to shift the graph vertically, but when it's on the inside, it's going to shift it horizontally. And so a horizontal shift, when we are dealing with sine and cosine, is just going to be called a phase shift. And so we use this expression to figure out what that is. So the next thing we're going to do is look at an equation and figure out what the amplitude, period, and phase shift are. So here we have y equals -4 cosine of 4x plus pi over 2. So the amplitude is just going to be given by the absolute value of -4, and that's just going to be 4. So our amplitude here is going to be 4. So now we just want to find our period and our phase shift. So we're going to set bx plus c equal to 0. And so, well, actually, remember, we know what these things are. So we actually don't have to do it from scratch. We know that the period is 2 pi over b. And so if we just plug in those values, we're going to get that b is 4. So we get our period is 1/2 pi, which we should just write as pi over 2. Okay, so here's our period, and our phase shift is given by -c over b. So our c here is going to be pi over 2. And our b here is going to be 4. So to actually do this division, we're going to do -pi over 2, and we're going to think of 4 as 4 over 1, and we're going to multiply by the reciprocal, so times 1/4, and we're just going to get -pi over 8. So that's going to be our phase shift. Okay, so now let's look at the next example. We want to find the amplitude, period, and phase shift for this new function, y equals 4 plus 2 times sine of 3x minus pi over 2. So one thing to note is that this is the graph of y equals 2, I'm going to run out of room, of y equals 2 sine of 3x minus pi over 2 shifted up 4 units. So what does that mean? It means that all we're doing is taking this graph, and I'll highlight it. That was kind of interesting, maybe a different color. But all we're doing is taking that graph and we're shifting it up 4 on the y-axis, and so nothing's going to change. The amplitude, period, and phase shift will still remain the same. So we can just look at this equation instead of the original one. So our amplitude is going to be given by just the absolute value of a, so that's going to be the absolute value of 2, and that's just 2. So we've got our amplitude. Our period, remember, is going to be given by 2 pi over b. So we just need to be able to identify what those two things are. Well, one thing, just what b is. So b is going to be 3. And so we plug that into our equation, and we get the period, 2 pi over 3. Lastly, we want to write out the phase shift. And so that's going to be given by -c over b, and -c is going to be a minus -pi over 2, and b, once again, is 3. So we'll turn this into a positive pi over 2 because the negatives cancel out, and I'm going to times this by the reciprocal of 3 over 1, which is 1 over 3, and I'll get pi over 6. So I have identified the amplitude, the period, and the phase shift of this function.